Hello, working? Is it working? Not audible. Is it connected here? Am I audible? Okay, now it is audible. This time it was not audible. Now it is audible. Okay. All right, everyone. Okay. Voice ledu ni voice unda. Voice unda. Yes. Good afternoon. Good afternoon, everybody. I was just asking whether you have enjoyed the classes till now or not. If you have all enjoyed the classes, just put a thumbs up. If you have enjoyed the classes, just put a thumbs up. Good evening to all of you. I was taking your names when the mic was not on, so I've taken all your names. 131 viewers are there. See how many thumbs up we get. We'll come to know that how many have enjoyed the classes. Khalil, Faz has enjoyed. Good evening, everybody. Yashasvi enjoyed. Good. Venkat, good. Devil Potter, Malikarjun, good. Chetna Priya, that's great. Very good. Anivesh. Nimrat, yes. Good evening, yes. Reshma, Yashwant. Okay. So this is going to be our, final class. This is going to be our final class for this bridge course. So when you come back, then you will continue with your syllabus from the start. That's a very good thing. Good. Thank you. So you can like the video also in time, within the time we start our class today. You can start liking the class, and then I'm going to start teaching you the topic. Okay, good. That's a great thing. That's a good thing. 95% of people have said that they have liked the classes, and same way the whole 2 years, if you keep listening the classes, and you keep doing your homework every single day, most probably all of you can clear NEET in next 2 years. Okay. This will be the last class. Offline classes will be started whenever you get the schedule beta. But for online, for the bridge course, this is the last class. Okay, let us start, everybody. So our last class should be as fruitful as our previous 19 classes, and let us start with it. You can stop the chat for some time. Okay, I'll start with the chats for all subjects. Okay, for all subjects. We'll be concluding the bridge course in today's class. Okay, it was a 22 days of bridge course. Since NEET exam is there tomorrow, so all of your, seniors are going to write the exam tomorrow. For that, we'll wish them good luck, and we'll conclude our classes so that offline classes will again continue whenever you come back. All the chapters again will be dealt in details. We have not done anything yet. It was all up to 0 I brought you. Let's say you were at -2 level. I have brought you to 0. If anybody was at 0 level, I have brought you to +2, +3 level. Okay, out of 100, let's say. So 1-2% extra knowledge only you have gained. This knowledge will be repeated again anyhow in your regular classes. Okay, whichever campus you join at, same thing will be repeated again. Maybe in a different manner, because this particular chapter, chemical bonding, that I am teaching you, every teacher has a different way to approach to the structures making, but all the methods are absolutely same, are absolutely correct. but have some different kind of calculation. Like I have told you TVSU, some other colleague will be telling you some other way. So that's a good thing that you will learn extra new ways to draw structures. Today the structure drawing method that I'm going to tell you is going to be very easy. It will give you hybridization also within half a second. Okay, let us start. So in the last class I have told you about hybridization. 5 points we wrote. 2 more points we'll write about hybridization and then we'll continue. Postulates of hybridization that you have written till now are these. Let us quickly revise them. Mixing atomic orbitals must have similar energy and size shapes. Hybrid orbitals formed have identical shapes and identical energies. How many orbitals you will mix? Same number of new orbitals will be formed. This is also called as beta steric number. Okay, another name for this is steric number. You can remember it. SN, steric number. Steric means crowding. Means around central atom how much crowding will be there, how many orbitals will be there, 1 orbital, 2 orbital, 3 orbital, 4 orbitals, 5 orbitals. So if steric number is 5, means 5 atomic orbitals have mixed, 5 new hybrid orbitals have formed. Another name for this is called as steric number. Okay, we will be using this steric number today. So what is steric number? Number of hybrid orbitals around central atom. Okay, I'll just write this definition also. You can also mention it somewhere. Steric number. All of you can write. Steric number, SN I'm going to call it. Steric number is number of hybrid orbitals around central atom. Number of hybrid orbitals around central atom. So the type of hybridization will be told by steric number only. If steric number is 2, hybridization will be sp. Means 1s and 1p will mix. When steric number is 3, hybridization will be sp2. Like that we'll be writing one table today. Okay. Steric number I have told you what it is. Then we saw the next point, which was during mixing of pure orbitals, any type of orbitals can mix. Vacant, not in this chapter, later we'll see mixing. Half filled can mix, even fully filled orbitals can mix. This or this, anything can mix. Hybridization may take place either in ground state or excited state, as I showed you few examples where in ground state in ammonia hybridization was taking place, in first excited state CH4, second excited state SF6. And the last point we'll mention now, 6th point on hybridization we can mention. Point number 6 on hybridization you can mention. All of you write it down. After hybridization, the hybrid orbitals arrange themselves in a geometry in order to minimize repulsions between each other. In order to minimize repulsions between each other. This geometry of orbitals decide the geometry of molecule. So if orbitals are arranging themselves in a linear fashion, then the geometry of molecule will be linear geometry. If the orbitals are arranging themselves in a trigonal planar fashion, then it will be a trigonal planar geometry. For example, I'll show you. If there are 2 orbitals, steric number is 2, then the 2 orbital, this is the first orbital beta, this is the first hybrid orbital, and the second hybrid orbital will be 180 degree away from each other. So to have minimum repulsion, obviously when you are having, let's say, mother is at home and the 2 kids are there. When there are 2 kids and they are fighting, mother will say, one you sit on right side of me, one you sit left side of me. Then only you will not fight. Because if you sit in front of me and one sit in right side of me, you will start fighting again. A lot of repulsion will be there at 90 degree. So your mother will not make you sit together. Your mother will say to you, make you sit farthest away from each other, which is going to be at 180 degree. Same way, the two hybrid orbitals will arrange themselves at 180 degree and geometry will be linear like this. This is steric number 2. This is sp hybridization. sp hybridization. And steric number is 2. Okay, one simple rule I told you, whenever you draw a hybrid orbital, always show a plus sign in the bigger lobe, minus sign in the smaller lobe. Plus sign in the bigger lobe, minus sign in the smaller lobe. This sign represents sign of wave function. Let's say now 3 hybrid orbitals are there, that is sp2 hybridization. Remember the name of hybridization now, when steric number is 3 orbitals. So when there are 3 kids at home, then your mother will say that one you sit, so exactly 3 people, if you want to minimize their repulsion, we should keep them 120 degree away from each other in the form of a triangle. One you sit here, one you sit there, one you sit there. Otherwise 3 of you will fight. So if your mother is sitting in the center, she will make one child sit here, one child sit here, and one child sit here. So that now they are farthest away from each other. Any angle if I try to increase, let's say this child to this child, if I try to increase the angle and keep it here, then these two will start fighting. That is not good for us. Okay, so all 3 orbitals arrange themselves 120 degree away from each other, making exactly a trigonal planar geometry. So first orbital here, second orbital here, third orbital here, like this. First orbital here, second orbital here, third orbital here, like this. This is sp2 hybridization. And steric number is 3. Minus, minus, minus. Okay, this is how orbitals arrange each other. Now when the orbitals become 4, when there are 4 people to keep, then keeping them at in the form of a square is not good, because angle will be 90 degree, and 90 degree is a very small angle between 2 bonds and it will create a lot of repulsions. So in order to keep 4 orbitals, now we have to stop thinking about 2D shape. These are both 2D, 2-dimensional shape. Linear is on one page, and your trigonal planar triangle is also on one page. Then we have to think of a 3D shape, which is called as tetrahedral. So you should remember, whenever the hybridization is sp3, you will go for tetrahedral. So one is on the board like this, another one is also on the board like this. So these 2 orbitals are actually on the board only. They are at 109 degree angle, 109 degree 28 minutes angle, these 2. The third orbital will be coming out of the board. Okay, this orbital is coming out of the board like this. So this orbital is actually not on this board or not on your notebook that you are making. It is coming out of the notebook. And one will be going behind the notebook. This red one that I am making is behind the notebook like this. This is called as a tetrahedral. It looks like a tripod stand. You can think of it like a tripod stand like this. Okay, you can think of it like this. So the 2 that I have drawn are on the board, the yellow ones, this one and this one, they are on the board. One is coming towards you, one is going away from you, something like this. You can all imagine here. Something like this. Okay, this is on the board, the black one. This is also on the board. One is coming outside of the board, one is going behind the board, like this, a tetrahedral. Okay, this is how a tetrahedral looks like. All the bond angles are 109 degree 28 minutes here, like this. So let us talk about only these 3 hybridizations today. Other hybridizations you will be dealing with in the further classes. Hybridization can be one more than this also, sp3d, one more than that, sp3d2, one more than that, sp3d3. Total, 6 hybridizations you will be having in the syllabus. 6 hybridization: sp, sp2, sp3, these three, sp3d, sp3d2, sp3d3. Total 6 are there, but 3 let us talk about because time is less. So we'll be talking mostly about these 3 today. Okay, this is sp3 hybridization. Steric number 4. So whenever hybridization is sp, we'll call it linear geometry, beta. Linear, okay? Remember it. Linear geometry means in a line. Whenever hybridization will come sp2, we'll call it as trigonal planar geometry. Trigonal planar geometry, remember the name. And whenever it is sp3, we'll call it as tetrahedral geometry. Okay, this is all the points about hybridization. So now we'll make a table of hybridization and I'll give you a trick to find the hybridization. First I'll tell you the trick, then we'll do the table. Next we can write short trick to find hybridization. Short trick to find hybridization. With this short trick, we will be reaching to the steric number, and when we know the steric number, we can easily predict the hybridization. Okay, so we can just first remember this. We will be reaching to steric number and we'll be telling hybridization from there. If steric number is 2, 3, 4, 5, 6, 7, remember these hybridizations beta. Then with the trick we will reach there. Whenever by the trick you get steric number to be 2, hybridization name will be SP. 3 SP2, 4 SP3. Okay, steric number 4 SP3. There is nothing called as SP4. I hope you understand this because p orbitals are only 3 when you are writing electronic configuration. After using all the p's, you have to go for d. So we'll call it SP3D. Okay, steric number 5 means SP3D. 6 means SP3D2. And 7 means SP3D3. Okay, so once you get the steric number yourself by the calculation, that trick I am giving you, simple mathematics I am giving you. After knowing the steric number, you can tell the hybridization directly. And after knowing the hybridization, we can go for shape, geometry, everything. We can go for the shape, we can go for the geometry. Trick for finding the hybridization. Step 1. Step 1, all of you write it down. Find valence electrons, which you already know how to do. Find valence electrons V of the molecule given. Okay, whichever molecule I give you, you find the valence electron of it. At the same time also, let us take the example as well. Or I'll do one thing, I'll put these on the next page itself. Just a second, beta. I'll just put it on the next page. This, which one? Paste. First one. Where? Okay. Write down. Trick to find hybridization. Number 1. Step 1. find valence electron V. After finding the valence electron, you have to go for step 2. Now there are two cases possible. If valence electrons are 8 or less, then you divide the valence electron by 2. If valence electrons are more than 8, then you divide it by 8. Okay, step 2 is if valence electrons are less than or equal to 8, then divide V by 2. Divide V by 2. You have to divide it by 2. Whatever quotient we reach to, quotient, you know, all of you know the quotient, no? If I am dividing any number, let's say 20, I am dividing by 2, this will be quotient. This 10, this will be quotient. So whatever comes there as a quotient, that will be steric number, that's all, finish. That will be steric number. So then divide by 2, V divide by 2, quotient is equal to steric number. Quotient is steric number. Always quotient is going to be the steric number. Let us see the example, all of you. You can see here, example 1. I have NH3. I have H2O. Okay, I have NH3, I have H2O. If I want to find their hybridization and I want to find their geometry, what I'll be doing is, I'll be first finding the V, valence electron, and then I'll be dividing it by, 2 or 8 depending on how many valence electrons are coming. For nitrogen, valence electrons are 5. For each hydrogen, it is 1, 1, 1. So it is 8. So it is coming from first type of group, which is valence electron equal to 8. Whenever valence electrons are equal to or less than 8, what do? We divide it by 2. So we'll do 8 divided by 2. 8 divided by 2. How many times? It will go 4 times. And finished. This is the quotient. Quotient is 4. 4 is steric number, beta. 4 is steric number. So what is the 4 steric number hybridization? sp3. So this ammonia has sp3 hybridization. sp3 hybridization. Now I'll tell you how to reach to the structure also within this only. After this we'll be making one table as well. Hybridization is sp3. As soon as sp3 comes to your mind, you make a tetrahedral first. Make a tetrahedral. Nitrogen in the middle, central atom, and make a tetrahedral. 1, 2, 3, 4, like this. Okay. Then start putting the surrounding atoms. How many surrounding atoms we have? We have only 3 people at the surrounding. So only 3 places will be occupied. First place, second place, third place. Correct. Now if any place is left, if any of the hybrid orbital is left, make it as a lone pair. Make it as a lone pair. That is the only last rule. So this place was left, I will just make it as a lone pair, like this. This is the final shape. It looks like a tripod stand. We call it as pyramidal shape. The shape names will come later. Right now, just one example I am telling you. So the geometry of this came out to be, geometry of electron pairs came out to be tetrahedral. But the shape of molecule, while checking the shape of molecule, what you have to do is, beta, while checking the shape of molecule, you consider lone pair to be invisible to you. Shape only means we have to see where the bonds are attached, not the lone pair. Okay, so this is tetrahedral, but when I remove the top part, now it becomes just a pyramid. It becomes just a pyramid. So this is called as pyramidal shape. Pyramidal shape. Okay. Most of you might not know the names of the shape. Don't worry about it. Just today's topic is to find the hybridization by the trick, not the shape. Shape is not important. Hybridization is important. sp3. Done. Let us do one more example. Let us do one more example from second type now. If valence electron come more than 8, if V is more than 8, then what should we do? If the valence electrons are coming like 24, 32, 40, then you divide V by 8. You divide V by 8. Maybe V will be completely divisible by 8, something like 40, 32 or 24 or 16. But sometimes V will not be divisible by 8. For example, 26 is not divisible by 8 completely. Something like 22 is not divisible by 8 completely. Then when you divide it by 8, any remainder will remain. Divide the remainder by 2. Divide the remainder by 2. So first divide the valence electron by 8. If anything is remaining at the end, divided by 2, then check the quotients. 2 quotients will come. Okay, then sum of those quotients will give you steric number. So if valence electrons are more than 8, then divide V by 8 and any remainder by 2. And any remainder divide by 2. If any valence electrons are going to be directly divisible, division by 8 is sufficient. In case any remainder is remaining, then divide the remainder by 2. 2 quotients you will get. From here you will get quotient 1, from here you will get quotient 2. Quotient 1 plus quotient 2 when you do, that will give you steric number. That's all, finished. That will give you steric number. I'll show you examples, don't worry. I'll show you all the examples. First you write it down. Okay, let us see next example. Example number 2. Example number 2. Let me take the example of BeCl2. BeCl2. Okay, if you want to draw the structure of BeCl2 and want to find the hybridization of BeCl2, how should we start? We'll say valence electrons are beryllium. Beta, beryllium belongs to second group. Beryllium, magnesium, calcium, all of them belong to second group. So valence electrons of beryllium are 2. And chlorine has 7 valence electrons. So 2 chlorine will have 14. So we get valence electrons as 14 plus 2, 16. 16 is more than 8, so we have to divide by 8. 16 divided by 8 goes 2 times. Nothing is remaining. Nothing is remaining. So only one quotient is there. So 2 is the steric number. When steric number is 2, we know that hybridization will be sp. Hybridization will be sp hybridization. sp hybridization means what was the geometry beta? It was linear. So I'll keep beryllium in the middle and I'll think of a linear geometry. One this side, one this side. Since I have 2 surrounding atom, 2 chlorine, so I'll put 1 chlorine here, I'll put 1 chlorine here. So it is a linear geometry and a linear shape as well, no lone pair on the beryllium. So geometry linear, shape linear. Geometry linear, shape linear. Okay, I'll give you some time to grasp it, all of the things that I've just told you, and then you can tell me whether it is clear to you or not. I'll just tell you once more what I have done. What I have done is to find the hybridization. Just worry about hybridization. Shape I will help you to find. To know the hybridization, you will find the valence electron. If valence electrons are coming 2, 4, 8, 6, then you divide by 2. When you divide by 2, whatever quotient is remaining gives you steric number. Steric number is 2, sp, 3 is sp2, 4 is sp3 and so on. Once you have got the steric number 4, you will draw a tetrahedral in your mind. After drawing a tetrahedral, then you will start putting surrounding atom. Center mein to you have to keep the atom which is lesser in number, only nitrogen is the central atom. Surrounding mein only 3 people we can keep. So out of the 4 places, 3 places hydrogen will come. Other remaining place a lone pair will come. Okay, that is the case. Geometry, tetrahedral I have told you. Shape is pyramidal, you can learn it now. Whenever you have a tripod stand like this, it is pyramid. Then BeCl2. Second case, if valence electrons are 8, more than 8, then you divide it by 8. If it is completely divisible, good for us, steric number is 2, sp. One more example let us see, and then I will ask you whether it is clear to you or not. One more example I am going to ask you. You can first write it down if you want, and just tell me in the chat box if it is clear to you or not. Just mention crystal clear if you are clear with how to find the hybridization. Then we'll do 2 more examples. You can open the chat. Chat is open for you to answer. I'll take any doubts if you have any, but I hope it will be clear to you because I've told very slowly only. I didn't rush up at all in this topic. You can tell me. It is clear. That's good. Thank you very much. Okay. So once it is clear to you, I can ask you a question now. Okay. Once it is clear to you, 5 molecules I am writing here. All their hybridization you will find. Okay. Since it is clear to all of you, I'll write 5 molecules here. Beta Q1 plus Q2 Pushpa, here only 1 Q came. No, Q1 only came. Q2 did not come here. One more example of Q1 plus Q2 also, let me tell you. You can see here. You can see here one more example I am writing. Let's say example number 3, a molecule is given to you which is XeO2 F2. Okay, beta. XeO2 F2. Okay, if I want to check this one, who asked Q1 plus Q2, all of the other people can also see this. First thing, valence electron, xenon 8, each oxygen 6, 6, each fluorine 7, 7. So V comes out to be equal to 8 plus 12, 20, 20 plus 14, 34. V comes out to be 34. Now I'll divide 34 by 8. First it goes 4 times 32, but it is not completely divisible, not something is remaining. So whatever remainder is remaining, then you divide the remainder by 2 also. Divide the remainder by 2 also. Now the next time the quotient comes 1, 2 ones are 2. Now it is completely gone. So this is Q1 beta, this is Q2. Add them. 4 plus 1, 5. 5 is steric number. If steric number is 5, we know that hybridization is going to be sp3d. What is the shape is a later part. I have not told you how to find the shape for sp3d, but hybridization is clear to us that how we will find for them. sp3d is the hybridization. Is it clear to everyone? Yes or no? Yes, sp3d. Good. Good. Now I am writing few molecules. I want you to find the hybridizations of all of them. Okay. So this is your work. Find hybridization in following. The geometry will be clear from hybridization itself. Shape you will be doing in your offline classes only. Okay. Shape you will be doing in your offline classes only. All of you do the first one as water, second one CO2, third one NO3 minus, fourth one SO2, fifth one SO3, sixth one PCl5, seventh one XeF4, eighth one XeOF4, ninth one SF4, 10th one ClF3, 11th one XeF2, 12th one BrF5, and the last 13th one IF7, and also the 14th one XeF6. Okay, so after finding their hybridization, you can tell me the answer as 1 is equal to this, 2 is equal to this, 3 is equal to this. I'll check it. And so I told before also, this is going to be our last class for the online. So I hope all of you have enjoyed well. You can just hit the like button if you have. 88 likes are there. And 193 people are right now in the class. So classes were complete from today. Yes, classes have completed today. You can quickly keep answering me what the answers you are getting. Venkat says 7th one is sp3d2, 7th one is sp3d2. That's correct. Good, Venkat. First is sp3. Good. First is sp3. 14th is sp3d3. 14th is sp3d3. That is correct. Good. Beta, bridge course is not something extra. It's just class 11th classes only. Okay. Third is sp2. Third is sp2. Correct. 14th is sp3d3. That is correct. Second is sp. That is also correct. Second is sp. 10th is sp3d. That is good. sp3d. So all of you can get the answer very, very quickly. Ninth is sp3d. That is also correct. 10th is sp3d. Anything else? 5 is sp3. No, 5 is not sp3. 5 is sp2. This is also sp2. Okay, all of you will check yourself. 6 will be sp3d. 8th will be sp3d2. 11th will be sp3d. 12th will be sp3d2. 13th will be sp3d3. Okay, you will do them yourself. I'll give you time. You keep doing them. If any doubt you are getting that you are not getting any answer correctly, you can just mention here. I will explain anyone also. First is sp3. Yes, correct. Okay then. All right, everyone. You can keep doing them. Sir, sixth one. You want sixth one? PCl5 you want? I can tell you the PCl5. You can see here. Sixth one. PCl5. valence electron. Phosphorus belongs to nitrogen family, 5. And chlorine belongs to, 7th. So 3, all 5 people have 7, 7. So it is 5 plus 35, 40. 40 divided by 8 goes 5 times, exactly. So 5 is the steric number. 5 means sp3d. sp3d. Reshma, all the topics are almost covered, because any more classes if we take, that will not be much fruitful. All the important topics which were to be covered, whatever would be given in your schedule, are already covered. Okay. So this is all about it. When will books be given? When you come here, Bharti, after you join here, you will get all the books and modules and everything. Sir, explain the third one. NO3 minus, third one. Valence electron, just normal beta, normal only. There is nothing special about any anion. 5 for nitrogen, 6, 6, 6 for oxygen, and 1 extra electron is added because of negative charge. So what do I get? 5 plus 1, 6. 6 plus 18, 24. 6 plus 18, 24. 24 divided by 8 goes how many times? 3 times. 3 means what? sp2. Okay. All right, everyone. Just say bye-bye now. That's our, story till now. We will be meeting again once you join here. When you come back to Gosala Center, you can all come and meet me. Okay. We'll be meeting in the classes as well. So that's all. Thank you. Bye-bye. Take care. It was a pleasure to teach all of your wonderful kids, and I'll see you all later now. Okay, bye bye. Going to miss you. I'll miss you all too. Thank you. Bye bye. Bye bye. Bye bye.